Hello everyone. Here is topic 2 for exam 3. It's integrating even powers of sines and cosines. So as opposed to case 1, where we had our little strategy of isolating the factor of the smallest odd power and such, there's no strict strategy or procedure here except for the fact that you have to use what I like to refer to as the power reducing double angle formulas. Some people call these power reducing, some double angle. I like both names because if you look at the formulas, you've got a power such as sine squared that reduces to just the cosine of, notice the angle is now 2 theta, so instead of theta there's the angle 2 theta, so the angle has doubled. So hence the name power reducing as well as double angle. And that holds true for cosine squared as well. So when you have even powers, if you have odd powers of sines and cosines, just go with the case 1 method. And if you have even powers, then you need the identities. So in this first example, we just have cosine squared of 3x. I won't bother recopying the integral and just jump right to the identity. So we get the integral of cosine, well, squared of, now our theta is 3x, we have 1/2, and then times 1 plus cosine of twice the angle, so therefore 2 times 3x, 6x. And that's all with respect to x. Now, to make the integrations clear, let's separate this into 2 integrals. So we'll have 1/2 integral 1 with respect to x, and then plus 1/2 integral cosine 6x with respect to x. And now notice that each of those are readily integrable. That is, 1 integrates to be x, and here we have plus 1/2 times, remember the integration rule for cosine of kx, cosine of a linear argument, positive 1 over k sine of kx. So cosine of 6x becomes positive 1 over 6 sine of 6x. And we'll add our constant there. And then just maybe make this look a little bit better. Multiply the 1/2 and the 1/6 to get 1/12. Sine of 6x, and then plus your constant, and that's all there is to it. So it gets a little more interesting when you have a higher power. I doubt we'll go past the 4th power, but let's look at this. We're going to use that concept that we used last time. For example, sine to the 4th of theta is sine squared of theta, but as a quantity squared. So therefore, we would have to take the identity and square the whole thing. So I'm going to use brackets here. So it would be 1/2 times 1 minus, and then cosine of twice the angle again, but as a quantity squared. So applying the identity here, we'll have the integral of, again I'm going to use brackets. The identity is 1/2 times 1 minus cosine of twice the angle, so the angle was 5x, so double it, 2 times 5x, 10x, but that whole quantity needs to be squared, and that's with respect to x. So we'll have to square the 1/4, or excuse me, square the 1/2 to get 1/4, and then we'll have to square the binomial, 1 minus cosine of 10x. So if you have to go off to the side, 1 minus cosine of 10x times itself, and FOIL it out. But squaring a binomial, shortcut method, square the first, 1 squared is 1, twice the product, 2 times 1 times negative cosine 10x, negative 2 cosine 10x, and then square the second, squaring negative cosine 10x, we get positive cosine squared of 10x. Okay, and then at that point, again, to make it simpler, let's separate this now into 3 integrals. So So 1/4 integral of 1 with respect to x. 1/4 times the negative 2, negative 1/2. Integral cosine of 10x with respect to x. And then plus 1/4 integral cosine squared of 10x with respect to x. So notice that the first two integrals are readily integrable, but this third integral is again an even power of sine or cosine. So here we're going to have to apply the identity again. Okay, so I'm going to save all the integrations for the end of 1/4 the integral of 1 with respect to x minus 1/2 integral cosine 10x with respect to x, just recopied. Then play out the 1 plus 1/4 integral. Okay, now the identity on cosine squared of 10x. Okay, back up to the identity. It's 1/2 times the quantity 1 plus cosine of twice the angle, 2 times 10x, 20x with respect to x. So now I'm just going to recopy the first two integrals. And then separate this into two integrals with 1/2 times the quarter, 1/8. Integral 1 with respect to x, and then plus 1/8 integral cosine 20x with respect to x. So now everything is readily integrable, and so we'll integrate. So 1/4 integrating 1 with respect to x, you get x minus 1/2. Here's our linear argument I wrote again. Cosine 10x integrates to be 1/10 sine of 10x. Plus 1/8. 1 integrates to be x again, and then plus 1/8. And cosine of 20x is 1/20 sine of 20x. And then we'll add our constant of integration at that point. And then we'll just multiply these fractions together. Also notice that you can actually combine the 1/4 and the 1/8 to get 3/8 x. And then minus 1/20 sine of 10x and plus 1 over 160 sine of 20x plus our constant. Okay, so that's actually it for topic 2, and we'll see you in a few minutes.